There's a photograph floating in space right now that nobody wanted to see. Not because it isn't beautiful. It is. Thousands of galaxies, each one containing billions of stars, captured in a single frame. But this photograph has a problem. It's showing us things that shouldn't be there. Galaxies that are too big, too organized, too perfect. Galaxies that formed billions of years before our best theories say they could. The James Webb Space Telescope was supposed to confirm what we already knew about the universe. Instead, it's revealing something far more unsettling. The cosmos is bigger than we measured, faster than we predicted, and stranger than we ever imagined. Every answer JWST gives us spawns 10 new questions we don't know how to ask. This is the story of how humanity looked deeper into space than ever before, and found out we understood almost nothing at all. Let's start with something that sounds like science fiction but is absolutely real. Right now, as you watch this, you're looking into the past. The light from your screen takes a few billionths of a second to reach your eyes. You're seeing the past. The sun you see is 8 minutes old. The stars above you? Some of them died centuries ago, but their light is still traveling, still reaching us, ghosts in the cosmic machine. This is the universe's greatest gift to us. Light is a time machine. The James Webb Space Telescope uses this principle to do something extraordinary. It doesn't just look far into space, it looks far into time. When JWST gazes at a galaxy 13 billion light-years away, it's not seeing that galaxy as it is today. It's seeing that galaxy as it was 13 billion years ago, when the universe itself was just an infant, barely 700 million years old. Think about that. The universe is 13.8 billion years old. JWST can see back to when it was only 5% of its current age. It's like having a photograph of yourself as a newborn and being able to zoom in to see individual cells forming. We expected to see a universe that was dark, simple, primitive. A cosmic nursery where the first stars were just beginning to flicker into existence. What we found instead was a city already built. In July 2022, JWST sent back its first deep field images. Astronomers stared at their screens in silence. They weren't looking at primitive proto-galaxies slowly assembling. They were looking at massive, mature, impossibly organized structures that had no right to exist. According to every model we had, galaxies in the early universe should be small, chaotic, messy. It takes time for gravity to pull matter together. It takes time for stars to form, to die, to create the heavy elements needed for new generations of stars. Time that these galaxies shouldn't have had. Some of these galaxies are so massive, so structured, that they would have needed to form in just a few 100 million years. That's like expecting a single-celled organism to evolve into a blue whale in the span of a human lifetime. It shouldn't be possible. But there they are, staring back at us from the edge of time. This isn't a small problem. This is a crisis. Either our understanding of how galaxies form is completely wrong, or something else was happening in the early universe that we don't understand yet. Dark matter might have been denser. The laws of physics might have behaved differently. Or perhaps, the universe itself is older than we think. Each answer opens a door to something we can't explain. The cosmos is hiding something from us, and JWST just found the evidence. Now let's talk about something truly terrifying: the edge of everything. There's a boundary out there in the darkness, a horizon beyond which we can never see, no matter how powerful our telescopes become. It's called the cosmological horizon. The universe is 13.8 billion years old, but the observable universe, The sphere of space we can actually see extends about 46.5 billion light-years in every direction. Wait, how is that possible? If the universe is only 13.8 billion years old, shouldn't we only see 13.8 billion light-years out? Here's where it gets strange. While light has been traveling toward us for 13.8 billion years, the space between us and those distant objects has been expanding. Not through space, but space itself, stretching like fabric. So by the time that ancient light reaches us, the object that emitted it is now 46.5 billion light-years away. But here's the nightmare. There are galaxies beyond that horizon. Galaxies we will never see. Not because they're too dim, not because our telescopes aren't powerful enough, but because the light from those galaxies will never reach us. The space between us and them is expanding faster than light can cross it. In fact, as the universe continues to accelerate its expansion, more and more galaxies are slipping beyond this horizon every second, vanishing forever from our observable reality. Imagine standing on a beach, watching islands disappear over the horizon, one by one, knowing you'll never reach them, never know what was there. That's our position in the cosmos, observers in an expanding void, watching the universe erase itself from view. JWST is giving us one last look before the curtain falls. There's a war happening in the universe right now, a war between two invisible forces that will decide the fate of everything. Dark matter, dark energy. Together, they make up 95% of the universe. Everything you've ever seen, every star, every planet, every atom in your body is just the leftover debris, the 5% that didn't get claimed by the darkness. Dark matter is the scaffolding, the invisible gravity that holds galaxies together, that shapes the cosmic web. Without it, galaxies would fly apart. Stars would scatter into the void. We can't see it. We can't touch it. But we know it's there because we can see its effects. Galaxies spin too fast. Clusters hold together too strongly. Something massive and invisible is pulling the strings. Dark energy is the opposite. It's not pulling. It's pushing, tearing, accelerating. In 1998, astronomers made a discovery that won them the Nobel Prize and terrified them at the same time. The universe's expansion isn't slowing down. It's speeding up. Something is pushing space apart with more and more force. And we have absolutely no idea what it is. Think about that. We've named it dark energy, but that's just a label for our ignorance. We don't know what it's made of. We don't know where it comes from. We don't even know if it's a force or a property of space itself. And here's the war. Dark matter wants to pull everything together. Dark energy wants to tear everything apart. Right now, dark energy is winning. If it continues in trillions of years, every galaxy beyond our local group will be pushed so far away that their light will never reach us. The sky will go dark. The universe will become isolated islands of matter in an infinite, expanding void. The Big Freeze, heat death, cosmic loneliness. But JWST might help us understand these invisible combatants before the battle is decided. Each galaxy it observes, each structure it maps, gives us clues about how dark matter and dark energy shaped the cosmos. We're watching the war through the evidence left on the battlefield. And now, the crisis that keeps cosmologists awake at night. It's called the Hubble Tension, and it might mean we've been wrong about everything. Here's the problem. We have two different ways to measure how fast the universe is expanding, and they don't agree. Method 1. Look at nearby objects, supernovae, and variable stars, and measure how fast they're moving away from us. This gives us a number, about 73 kilometers per second per megaparsec. Method 2. Look at the oldest light in the universe, the cosmic microwave background, the afterglow of the Big Bang itself. Use our models of cosmic evolution to calculate the expansion rate. This gives us a different number, about 67 kilometers per second per megaparsec. 6 kilometers per second doesn't sound like much, but this isn't a small measurement error. These are two precise, independent methods that should agree, and they don't. Either something is wrong with how we measure the nearby universe, or something is wrong with how we understand the early universe, or something else is going on that we haven't discovered yet. Some think there's new physics we haven't discovered. Others believe dark energy might be changing over time. Some wonder if the universe isn't expanding uniformly, if there's structure or variation we can't see yet. The JWST is now the referee in this debate. Its measurements of distant galaxies, its observations of the early universe, might finally tell us which method is right, or it might tell us they're both wrong. Every week, new data arrives. Every month, new papers are published. The tension isn't resolving. It's getting worse. We're approaching a moment in science where we have to admit that our standard model of cosmology, the lambda CDM model that's guided us for decades, might be incomplete. The universe is trying to tell us something. We just don't speak the language yet. The James Webb Space Telescope has been operational for less than 3 years, and in that time, it's forced us to question nearly everything we thought we knew. The universe is bigger than we calculated, older than we predicted, stranger than we imagined, galaxies that shouldn't exist, an expansion we can't explain, invisible forces locked in a war we can barely comprehend, and a horizon beyond which the cosmos hides its deepest secrets. But here's the beautiful thing. We're asking the right questions now. We're looking at the evidence. We're following the data wherever it leads, even if it leads us to the edge of our understanding. Every image JWST sends back is a piece of a puzzle we didn't know existed. Every discovery is an invitation to wonder, to question, to explore. The universe is vast. The universe is strange. The universe is far more magnificent than any story we could invent, and we're only just beginning to see it. What do you think is out there, beyond what we can see? What secrets is the universe still hiding? Let me know in the comments below. And if this video changed how you see the cosmos, subscribe for more deep dives into the mysteries of reality itself. The universe is calling. Let's answer.